Shinde sir,
Yes, sir.
you are
Yeah.
ready? Sagar
Yeah.
Shinde.
Yeah.
Okay.
Definitely. Yeah. Yes. So very good morning to one and all.
Very good morning to all, and very warm welcome to all of you for today's third day session. That is the last day of IBM Skill Build program. And I heartily welcome to Mr. Sagar Shinde sir. He is a master trainer from EduNet Foundation. So in today's session, we are discussing regarding the data handling with NumPy and Pandas library. The both libraries are very most important for the machine learning, deep learning. So definitely I request to all participants, please listen carefully because these libraries are very most important for the futures of machine learning, artificial intelligence. So I request to Mr. Sagar Shinde sir, sir please start for the last day of session. And very warm welcome to all of you.
Thank you. Thank you. Thank you very much, sir. So I welcome you all and good morning all. Let me quickly share my screen with you people. Yeah. So as we have discussed yesterday, right, we will be talking about the data handling part over here into this session, right? But prior to that, let me just give you a quickly idea about how we can do it with the help of simple Python functions, right? That we'll try to see, and then we will go to the packages which will help us in handling the data, right? Either from files or from some sources, basically, right? So let's try to go for Python first. Again, I will request you people to launch a fresh Colab notebook over there on your machines. Go for it. You know how to do that, right? Go to Google, search for Google Colab. Go for a new notebook over there. You can give a suitable name which you feel Day-3 or data handling in Python to that notebook. And then connect your environment. Okay, so it will initialize the hardware and memory support for your notebook over there. Okay. One thing which we have to do here before we start our practical is to create a file. Okay. So for that, we will require that file to be either in the running instance or running memory of this particular notebook or somewhere there on your Google Drive if you can connect it. So for connecting the Google Drive, you have this files tab. Click on that. Okay. And you have to mount your drive. So as of now, for me, the drive is already mounted. For you, it will not be like that. It will say that mount drive. Click on that. So it will ask you for the permission whether you want to connect to the uh, drive or not. Let me just unmount it. Okay, let me just do it. Okay, so as of now, it is unmounted. I can go for mounting it by clicking on it. So it will ask me connect to Google Drive. I have to go for it. And once I do that, there should be one folder in the name of drive, which is available over here. If not, you go for refresh, right? And then that folder will be available. That directory will be available. So go to that directory, and into that directory, you have to go for my drive. Okay. And into that, what I want from you people is create a file. Okay. So for me, I have created one file in the name of python.txt. It is already there. You can see python.txt. Let me just open it up for you people. Yeah, this one. Okay, so you can edit the files over here also into Google Colab, right? Text files also, no worries about it. So I've given some text into that particular file. How you will be able to create a new file? So for that, you just have to, I guess, right click onto that, and you have to go for new file. So right click on that particular folder and go for new file. So that file will be created. You can give name to it. Maybe you can just have the same name which I have over here, over file, for my file, right? And put something into it. Once you create it, put something into that particular file. Anything, whatever you prefer, right? There should be some content over there. That is the thing, right? And once you do that, go for Control S to save this thing. Okay, right? So that is what is first of all required before proceeding to the practical part of it. Okay, so I will close this for now, and let's go for, I will wait here for a moment so you people will be able to do that. Okay, so now we'll go for our file handling part, and with the help of only Python, right? We will not utilize any package for that. So there is one inbuilt function which we can utilize for opening a particular file and either doing reading or writing, or any other operation which you would like to do over there onto a file. So for that, that function is open. Okay, it's a predefined function, and into which what you have to pass is the path for the file. So you can see the syntax over here for open. First of all, the first positional argument is the file itself, right? The path of it, basically, right? So I have to give the entire path of that file, what I want, which I want to read or write, or any other particular operation. Then I have to tell in what mode I want to open this file, right? So here I want it to open for, first of all, reading. I want to showcase you people how you can do read from a particular file, right? So mode should be defined. So it should be read, write, or whatever you want to go for. Like for example, uh, truncating the file, right? X is there for creating the file, right? And there are multiple options for that, right? Guys, if you are asking any question, you can go for it. I think I have heard something. I'm not sure. Okay, no worries. So you have to give the mode after that, after your file name, total path name, right? So that is two things which are mandatory over there for this open method, right? And then what is happening is that whatever you will read from this file needs to be stored somewhere, correct? Because you need to create an object which can be utilized as a variable, right? So with this open method, whatever will be the output, that needs to be stored into a variable. Let's say that variable is 5. Okay, for example, I have given it the name as 5. So this became the object of a function, a method, right? It cannot be directly utilized. Okay, so as it is a instance or object of a function or method, basically, right? So you have to take out the data from this also, right? And for that you require another method from inbuilt method from Python, that is read. So that you can apply on this particular object, and then you will get the actual data which you require from that file, the text data or whatever the data you have edited over there, right? And that I'm storing into another variable data, and that I'm going to print also. One more thing over here, if you utilize open, okay, it means that you have given the access to this particular file for whatever operation you want to do with it, right? So for that you made it open, right? You have opened it basically, right? So in case with this open method you forgot to close it, okay, after your operation performed, if you forgot to close it, might be by some mistake, right? uh, some other operation will be performed onto it, will get performed onto it, and whatever the data you have, right, it will get either overwritten or something will happen with it, right? So always remember that whenever you utilize open, right, you have to close that file also with close method, okay? Otherwise there is a probability that different lines of code which are coming after this will change the content of this file. That might happen, and that we definitely don't want to happen, right? Because that data can be very important also. Okay, so this is how you can read a file. Okay, and how to give this path, entire path? So for that, whatever the file you have created, okay, just go to it, right click, and go for copy path, right? And give that path into this particular field, first field, into your quotes. Okay, so this is reading a file. Go for it, try it out. I will wait here for a few seconds. Okay, in a similar manner one can write to the file also, right? So for that you just have to change the mode in which you are operating. So from write you have to change that mode to from read you have to change that mode to write. That is what is the small change you have to do over there. Okay, and then you have to tell what operation you have to perform. So here we were performing the read operation, but now we will perform the write operation over there, right? On the file, write operation on the file, and into that we have to tell what we have to write to the file. Okay, and again as we are using open over here, right, we have to close that file off after this particular operation is performed. So file dot close. But with this what will happen, that the existing content, right, operation is like that, the existing content whatever you have, right, this is your content as of now, right, it will get wiped out, it will get overwritten with the new content. That is what is going to happen. Okay, to prove that I will execute this first of all for the write operation, and again I'm going to read my file just like what we have done earlier, right? I'm going to read my file again. So you'll find that the content got overwritten. This is the only content which is present as of now into the file, and this thing got wiped out, right? So this is what is write operation, read and write basically. Go for it, try it out. I'll wait here for a moment. Okay. One alternative to this is rather than overwriting the existing content, you can append to the existing content, right? Appending means adding something after the existing content, right? So that is what is append. So you, for appending, you just have to change the mode of operation. You have to make it append into your open operation, right? You append, and with that, whatever object you create, onto that you go for a write operation. But here, this will not overwrite. This will append basically, right? So I'm adding the other line, the other content that is new. This is new line 3 into it, and then as per our, what do you say, process, we are closing our file dot close, right? So this is append. To check out whether it really got appended or not, we can read our file again, and it shows us the thing that yes, the whatever we have tried to go on for, go for appending, it got appended, it got added to the existing file. Okay, so try this out, append mode. Okay, but as we can see, we have to do this close operation manually, right, again and again. But in some of the cases, it will not be, it will be really difficult to do so, right? Because we are doing a lot of coding over there, and in that case, it might happen that we will forget it by chance, right? So that might happen. So to avoid this thing, there is another alternative which we can utilize, right? So that is utilizing with option, right? With statement. So you can go for open with statement, and uh, you know go for this syntax, that with open, whatever the file name is there, whatever your mode is there, as some file name. So as we were storing it somewhere, we are now doing it in this fashion. So we are saying as file1 colon, right? Then indentation, definitely, if you have a colon over there, because the rest of the things will fall into the block of this particular with operation, right? Then indentation, we are applying for loop over there, right? And we are iterating over file1. Okay, and we are doing it line by line. For us, there is only one line where the content is there, no other line is there. So that will just print out that single line only, right? So this way we can do the read operation basically, which we have done earlier with manually closing the file by ourselves, right? With this, if the content of the file is finished, right, with the for loop, this thing is going to get over, right? You don't have to do it manually. You don't have to close it manually. It will be closed after the operation is performed, right? So this is, I guess, a good utility to avoid any problem with manual closing of the file. Try it out. Okay. Now let's go for our packages. So first of all, try to understand the idea of what is a package, right? So when we say package, basically, package talks about a collection of different modules. Might be in those modules there are different classes. Might be in those different classes there might be different functions or methods, right? Or different constant and variables, basically, and all that, right? So package conveys the idea of a collaborative or you can say a collective a thing, right? A collection of different utilities, right? And when we utilize a package, we sort of save our efforts for doing the programming. So with that we can just apply the functions or methods or classes very easily. We can just call them and we can utilize them, right? That is what is the idea behind the package, right? And if you specifically talk about NumPy or the packages which are there with the Python or supported by Python for data analysis, they are all open source, right? And today we are going to talk about two of them. One is NumPy, that is numerical Python, and another one is Pandas, right? So starting about the NumPy, basically it helps you in creating arrays. Okay. Um, and with those arrays created with NumPy, there are different functions or different methods which are there into NumPy predefined, which you can easily utilize on that particular object which you have created, that array which you have created, right? So let me just get quickly an idea from you people. Do you know the concept of arrays? Can anyone unmute and tell me what is an array? Any idea what is an array? Yeah, go on.
Array are the variables.
Okay.
Array are the elements which share the same name and they are of same type.
Okay, wonderful. Okay. Yeah. So get the basic idea that array is basically a data structure, right? Okay. Where the elements of it needs to be or are basically of the same data type. So when we say data type, we have already seen what are the data types, right? Integer, float, Boolean values, or strings, basically, right? So these are the data types, and array elements needs to be of the same data type. So can anyone just try to answer this? Why we need to have array elements of the same data type? Is there any reason behind that?
Because we cannot create so many objects.
Okay. Let me give you a hint about that. So when we store arrays, right, its elements are stored in a continuous fashion, right? They are stored in a contiguous way, contiguous memory locations on the physical disk. Does that give you any idea, any hint about this? No one? Okay. So when we store the arrays, right, when we store the elements of the arrays, they are stored into the physical disk or memory one after the other. Okay. And there is no gap in between. They're stored just like, continuous, you can say, or contiguous, you can say, one after the other, just like that, right? And the way you fetch a particular element of the array, right? You access a particular element of an array, or you try to modify or manipulate a particular element of an array, is done with the help of something which is known as stride value. Okay. So what is that stride value? That is the total number of bytes one needs to move into rows and columns so that the person will reach to a particular element. That is what is the stride value. Number of bytes one needs to move into the rows and columns so that one person will reach at a particular location or element, basically. That is what is the stride value. So if you want to apply this kind of mechanism for either accessing or modifying a particular element of the array, then you need to consider there size when they will get stored. Because if you store elements with different data types one after the other, what will happen? They will have different sizes. Like integers, they will have different number of bytes. Floats, they will have different number of bytes. Strings, they will have different number of bytes. Boolean values, they will have different number of bytes. So it will become very tedious and difficult to say confidently that go these many number of bytes ahead and you will get this particular element, because it's totally random, right, in that case. But if you have similar data type elements into the array, what will happen? You will be confident that yes, I have only integers into my particular array, right? So the size of a particular element is same, correct, across my array, right? So I can say confidently that go these many number of bytes ahead and you will get your what do you say, that particular element, or you can modify it in place. That is possible, right? So this is the main reason you need to have your elements basically of the arrays of the similar data type. Okay, right? That is the main reason. And this also gives you this way of accessing the elements and manipulating them, also gives you speed factor, right, with arrays. So that I will try to explain by comparing it with the other data structure of Python, that is a list. Practically I will show you that particular thing, right? But let's get started with arrays quickly. So NumPy quickly, sorry for that. So for that, for getting the package, you need to import it. So for this Google Colab, right, this NumPy package is already installed in the background. If you run with Anaconda, for inside the Anaconda also, that package is already installed. If you don't want to do so, if you want to run out of the Anaconda but on your local machine, you have to install NumPy separately, right? So there are different ways to look at it. But for now, for our environment, NumPy is already there in the background. It is already installed. We just have to import it. So I will say import NumPy. So this is how you will import your NumPy. And I'm doing it with an alias. I'm giving it some alias basically, right? So alias basically is a dummy name for the standard name, right? So rather than saying NumPy everywhere, you will say NP. Okay? A simpler way to call the same thing. That is what is alias, right? So we will execute this cell. So we'll get our NumPy. And now onwards, we will say it as NP, right? We'll call it as NP. Okay. Now, the first thing is to create your array, right? How you will be able to create an array, and why we have to create arrays with the help of NumPy only. Why we can't just go for arrays? Because we know the concept of array. So why we have to fall into this NumPy and create NumPy arrays? So the reason being behind that particular thing is when you create arrays from NumPy, whatever the functionalities or whatever the different methods you have into NumPy, right, those can be applied onto that array, right? This is just like what we have seen into classes, right? So I have given you example yesterday about classes. So we have defined a class, we have defined different methods into that class, and then we have created an object out of that class, and onto that object we will be we applied different methods, right, which were defined into that class, right? That was possible, correct? So this is also the same thing. You are creating an instance of that NumPy in the form of an array, and onto that array you can apply different methods, right? So this is what it, in general it works like that, right? So how to define an NumPy array? So for that you have to take the method np.array, into the parenthesis of which you need to pass your data for creating the array. So let me first of all show you quickly a 1D array. Let me create a 1D array. You can pass that particular list, a single list into it, right, of 5 elements, and this will give you a 1D array. Okay, just to prove that we have created an array, and that is to offer NumPy origin, we can just apply type method onto that, and it will give you the answer. Okay, let's create a 2D NumPy array. So for that, just increase the depth of the list, right? Make it a 2D list basically, right? So how you will be able to make a 2D list? Just increase the number of lists inside that list, right? So let me give 7, 8, 9, and 10. So there are 2 lists inside one list, and that I'm passing to this array method now, right? So it will create a 2D list for me, 2D numpy array for me. Okay, so when I say 2D, two-dimensional, what I mean to say is that there are 2 dimensions. One of the dimensions is rows, okay, and another dimension is columns, right? Okay. Then one can look at the different features of the arrays with the help of different methods. Like for example, if I want to look at the dimensions of the array, I can apply ndim method over the array created. And this will give me the number of dimensions of my array. So this is the answer for that. That is 2-dimensional. I can look at the shape of the array. So what is the shape of the array? Number of rows, comma, number of columns, right? So you can take the name of your array and apply dot shape method over it. So for our array, which we have created, it is showing me the answer as 2 by 5, 2 rows and 5 columns, right? So 2 rows are, this is the row number 1. This is the row number 2. And columns, 5 columns are 1, 2, 3, 4, and 5. If you talk in terms of indexes, this is index 0. This is index 1 of rows, right? Okay. And this is index 0 for, this is index 0 for columns. This is index 1 for column. This is index 2 for column. This is index 3 for column. This is index 4 for column. Because indexing starts with 0, right? Okay. Then one can look at the size of the array. Size of the array means the total number of elements of the array, right? So one can do that with the dot size method. Okay, and how you will be able to calculate quickly the size of the array? Just multiply the number of rows with columns, right? So that will give you the total number of elements. That is 10. Okay, and then the important concept, that is of stride value, right? So I was trying to tell you about this only, how arrays access a particular element, or how the manipulation happens, right, in that manner. So this stride value you will be able to calculate with the help of strides method, right? So you apply strides method over that array and it will give you that stride value. So for this array, it shows that it is 40 by 8. Okay, let's try to understand how it is 40 by 8. So if you look at this array, if I want to move from this first location, that is the row number 1, to the row number 2, right? How many number of bytes I need to move in space? So for that, I need to move 5 different elements and then I will reach the next row, basically, right? That is how it is going to happen. If you want to calculate how many number of bytes will be required to travel across these 5 elements, you need to take into consideration the system also which you are operating with, right? So if the system is 64-bit system, if the installation which is there for these packages is of 64-bit system, then for storing each and every element of these, you require 8 bytes. For a 64-bit system, to store a particular element, you require 8 bytes over there, right? Now you have 5 elements. You require 8 bytes for storing one element, right? So how many number of bytes will be required in this case? 40, right? To cross from one row to the other. So this is the stride value for the rows. Okay, for this array I'm talking about, right? On the contrary, if you just have to cross your columns, right, how many number of bytes will be required? So you have to go from this place to this place only. You just have to pass one element for that, right? So how many number of bytes will be required? 8, right? This is for this particular array, right? So 40 by 8 is the stride value. Okay, that is how it is interpreted. For 32-bit system, the number of bytes which you will require for this will be 4. 4 bytes will be required for this. So it will change accordingly, right? Okay. Then one can find out the location from where the array starts onto the physical memory, right? One can point out to the, what do you say, the start location of it. So for that, you can do apply data method onto the array, and it will give you that idea. Okay, so this is how you will be able to look at different features or aspects of the array which you have created. Okay. Then a very important property which makes arrays popular as compared to lists or different data structures over there is broadcasting property. Okay, so let's try to understand this. So for that, let's try to go for, first of all, the concept of execution into list, right? So let's say, for example, I define this list of 5 elements. Okay, and I want to multiply each and every element of it with 2. So what will happen in that case? In general, it will come to your mind, let's multiply this list with 2, and everything will get multiplied in that case, right? That is the first thing which will come to your mind for sure, right? But if you do so, if you try to do so, you will find that the intended or the desired output is not there, and instead of it, the entire sequence got repeated. That is what happened, correct? Right? So this is not what we were looking for. So how to do it into list basically is you have to iterate over that particular list. Okay, and then do your operation. So you have to go for each and every element of it, do the operation, and store it inside the list. That is how it will happen, right? So you have to do list comprehension for that. This is what is list comprehension. This highlighted portion is list comprehension. So you take the square brackets for creating a list, then you mention your operation which you want to have, right, for a particular element, if that element is present inside your list, right? That is what is this particular list comprehension is telling you. That is W into 2 for W in L. So W over here is a dummy element which will take the value of each of these elements basically, right, while iterating over. Okay, this is how it will happen. But for this it is quite easy, because the number of elements are less, right? But consider that you have 10 lakh or 20 lakh such elements basically into your list. Then what will happen? It will become lot of tedious task for the computing facility also, correct? Both of these things, that is time and your space memory, right, it will also get affected. It will become very complex at that particular instance, right? So to avoid this, what one can do is, by the way, this print is just to add a new line character, space inside my outputs. That is the only thing which this print is doing. Yeah, now back to our concept. So if you, rather than that, if you create an array, right? So I've created an array out of that particular list L and given it the name as ARR1. You can simply multiply it with 2 and you can have your desired result. So this is your ARR2, right? And I'm not storing this result, right, anywhere. So it is just creating a view of that particular thing. So for that purpose, I've shown you ARR1 also. Like, this is the ARR1, original ARR1, right? But this is what is the intended output which we wanted, right? And that happened, right? We don't have to iterate over this object for that. So this is what is called as the property of broadcasting. What happens into it is that all the elements of the array gets exposed to the operation or manipulation all at once. Okay, it happens all at once. You don't need to iterate explicitly over each and every element and do the operation. It is not required. So this definitely saves you the time of manipulation as well as the complexity, a calculation complexity or computing complexity, right? This is how for large volume of data, arrays are preferred. Okay, right? So this is the reason behind, having arrays over there. So this is broadcasting property. I'll wait here for a few moments so you people will get chance to reflect onto that. Okay. Now, let's go for the other thing, how we will be able to access a particular element of an array, right? So I hope you people have gone through the questions, tried to solve them, which I have given for different data structures over there for Python. And from that, you would have got some idea about how to access elements of the ordered objects, right? So for that, you can utilize indexes of those, objects, right? So either it can be positive index or it can be negative index. So let's say, for example, from this ARR1, I want to access the first element of it, right? So that is with index 0, correct? Sorry, someone asked something. Okay. So if you want to go for the first element of it, you have to give the index, either positive or negative, right? So I'm giving it the positive index because for the first element, the index will be 0, right? So I can access it. This applies to any ordered object into Python, right? Because they have indexes for them, for their elements. Right? You can utilize negative indexing also. For example, I want to look at the last element of my array, ARR1. This is this 5, right? So I can say -1 in that case. Because for negative indexing, the last element will have the index -1, last but one element will have the index -2, and then -3, -4 towards the first element of your object, basically. Right? So here it will be 5. Okay, so this is how simple it is to access a particular element out of the array by using the indexes. Okay, there is another way also, but it is to look at sequence of elements rather than, right? So that is called as slicing. That term is called as slicing. And again, this is a generic thing. This is not only for arrays. This is a very generic thing. So any ordered object into Python can utilize slicing, right? So how it is done, basically, that we'll try to understand first, right? So the general syntax for that, you have to take the name of your array, then square brackets, then you have to define the start index. So what is the start index? Start index is the thing from where you want to look inside your array. So for example, let's say into ARR1, I'm interested into looking I'm interested into looking at the first 3 elements of it, right? So when I say first 3 elements of it, what will be the indexes in which I will be interested into? Index 0, index 1, and index 2. These will be the indexes in which I will be interested, right? In this case. So my start index should be index 0. Okay. Then I have to put a colon, and then I have to define a stop index, right? there is a catch into defining the stop index, however. So stop index should be always equal to required index plus 1. So what is the required index in our case? It is 2, right? Because that is the last element which I am looking forward to, right? So stop index, the required index is 2 basically. But what should be the value of stop index according to rule? It should be required index plus 1. So 2 plus 1. So that should be 3. That should be my stop index, right? So I will get my first 3 elements as a slice of my array. Here you can add step value also, right? So you must have seen that concept over there. So you can add a step value over here. Like, what is a step value? It's a jump between the different positions. So for example, while executing, we came to this place, then we gone for the second index, and then we gone for then we have gone for the first index, and then we are have gone for the second index, right? That is how we traveled when we were plotting our output, right? But if I give a step value, let's say 2, step value of 2, then what will be the output? The output will be, it will definitely go for the first value, and then it will jump 2 places ahead, right? Because the value is 2, step value is 2, it will jump 2 places ahead. So 1 and 2, and this it will print. So output will be 1 and 3. Let me run this. Okay, so this thing is called as step. Let me just add this step, or you can say simply say stride also. It is also called as stride. Okay, right? Yes, so this is about slicing. Then one can create multi-dimensional arrays with the help of some predefined functions. Those are called as universal functions. And the very popular one of them is np.arrange. This is just like the range function into Python, right? So into arrange, you just tell how many number of elements you require into the array, and it will get created for you. But this will just give you a 1D array. If you just execute this much part of it, it will give you a 1D array as a response, right? But what we are looking forward to is having a 2D array over here. So for that, on the top of this, we can apply dot reshape method. Dot reshape method, which will reshape that particular array, right? Whatever we will create. And how it will reshape it according to what number of rows we require and what number of columns we require. Right. So as of now, I have given it the argument as the number of rows required are 2 and number of columns required are 5. So if I print it, this is what I get. A 2D array, correct? To prove that it's a 2D array, we can look at the endim method of it, right? And we can look at the shape of it also. Okay. We'll wait here for a few seconds so you can reflect onto that. And there is one important point attached with it. So I will try to discuss that after this. Okay. Now, if we have created a 2D array, right, accessing the element of it becomes a bit tricky, right? Because here you can't just talk about a single what you say a single index. It's not possible, right? Because if you take a single index, it will just talk about one dimension, and it will not work, right? Because now the things are two-dimensional or multi-dimensional basically, right? So how to access elements in this case? So for that, what you have to do, you have to first of all take the name of the array. Okay, let's say you have a two-dimensional array. Then you have to first of all tell the index number for row in which you are interested into, and then you have to tell the index number for column from that row which you are interested into. So for example, let's say that I'm interested into this one. I want to access this one from this array ARR2. So I can say, first of all, that I am interested into a row with index 0, and from that row I'm interested into column with index 1, right? So that is what is given over here. Okay, so as the number of dimensions will go on increasing, let's say it becomes 3D basically, right? Three-dimensional. Then in that case, there will be different elements which will have their own rows and columns, right? That's how it will look into a 3D object. There will be different elements in which there will be rows and columns of those elements basically, right? So there you have to first of all mention the element index. Again, it will start from 0 to whatever the number of elements you have, and inside those element, after those element indexes, you have to tell what row out of that element you are interested into, and out of that row what column you are interested into. That is how you have to do the subsetting or the so-called access of that particular element, right? So as the number of dimensions go on increasing, this thing is also will go on increasing, right? Okay. Yes. So this was about NumPy arrays. I tried to cover some representative part of it. Now we will talk about pandas. And first of all, let's try to understand why we require pandas if we have something very powerful like NumPy over there. So with NumPy, you must have observed that we can handle only homogeneous kind of data, right? The data types which you can have for your elements needs to be of a similar nature, right? They can't be different data types, right? So that is one limitation which is there into NumPy. Second limitation is that NumPy cannot handle different file formats very easily, right? So it becomes very difficult for it because it deals with arrays basically, right? So it becomes difficult with NumPy to handle different files, right? So that is second thing basically which is there. Because of these limitations, there was a need of something which can address these issues and help us out and ease us with this process, right? And there came this package which was pandas, right? And which was named after one of the data structure which we can create with it, that is panel data, right? So it was a 3D data structure basically which we can create with that, but with the time, with the updated versions of pandas, it got obsolete, right? It is not there now. And the two popular which are still there into pandas which we can create out of it are series and your data frame, right? Data frame is quite popular. Everyone who do data analysis definitely create data frames, and they do manipulations on the data frame itself, right? It is a preferred way to do the things, right? So we'll try to see this, right? Pandas basically how it works, and how it helps us into data ingestion and data pre-processing for data analysis and machine learning purposes. So the first thing is always to get the package to import it. So I'm importing pandas, import pandas as some alias. So PD is the standard alias which is there for pandas, right? So just execute this to get your package. Okay. Then just try to go for any other CSV file over there, right? So I'm not sure whether I will be able to share with you people over here some file. Because I guess, let me just quickly check, just a second. I hope I can share here also. Okay, that does not Seem to be so. Okay. Yeah, I can't share over here a file. I can't share the file. Okay. So let's do one thing for the instance is you can go with any other Excel or CSV file which you have on your system, right? Go for it, right? Make sure that it will be uploaded to your drive. Okay, Google Drive. So the one which we have attached just a few minutes back, it needs to be there somewhere into your Google Drive, right? And you know how to take the path of it. You just have to right click onto that and copy the path of it, right? That way. Okay. So why we require it? Because I'm going to show you how easy it is to create a data frame. That is the data structure of pandas from external files, external file formats, right? So for that, you require a function from pandas that is read CSV. Okay, read underscore CSV. And into the parenthesis of it, you just have to pass the path of the file. Okay, that is what you require. And as of now, I have some file like in the name of insurance.csv. It's a data set basically for machine learning purpose that I'm importing over here. Okay. And with this, that data frame will be created. That data frame I'm storing into a variable named data. So what is a data frame basically? Data frame basically is a data structure which is a 2D kind of object, right? So there are some rows and there are some columns basically for it. And one very important thing about it, what is the difference between the arrays and data frames is that in the data frames, you can have heterogeneous kind of data. You can have different data type elements into the data frame. Right? That is what is the advantage of data frames over the arrays basically. Right? So I have created a data frame over here with that data which was there inside that particular CSV file. And to look at it, you can apply a method that is called as head. Right? So with head method, it will give you, if you just don't pass any argument into it, it will give you the first 5 records of your data to look at it basically, right? To have a glimpse of it. Okay, so there are many methods which are there with a data frame. I would definitely recommend you people to look at their official documentation, so you will find a lot of information. But we'll try to see just the introductory part of it to get you people started with this, right? Okay, and if you want to look at a different number of rows over here, you can just mention that number over here, and those many rows will be given to you. So as of now, if you see this data, right, which you see in the form of a number like 0 to 9, basically, these are the rows. Okay. And these things basically are the columns for you. Right. Again, there is a concept of row number and row value. You need to understand that particular thing, right? So when we say row number, basically, we talk about index of the row, right? So what will be the index of this row? It will be 0. What will be the index of this row? It will be 1. What will be the index of this row? 2, right? In that manner. And what can be the value of this particular row? Again, it will be 0. Here it is 0, right? But you can give any other index value also, like any name or any ABCD or whatever you want to go for. That is possible, right? That you can do. That is one thing. Second thing, if you look at the columns, these are the values of the columns. Okay, whatever the column names you are looking at, these are the values of those columns. If you talk about the number, index numbers of the columns, it is 0 for this, it is 1 for this, it is 2 for this, it is 3 for this, it is 4 for this, and so on. Right? That is what is the difference between an index value and index number. Okay, right? So that you need to keep into mind. Then just to prove that we have created a data frame, we can look at it by applying type method over it. Okay, so it will tell you that yes, it is of class pandas core object, that is data frame. Correct. Then you can look at the column names basically, which are there into that data frame with dot columns method. It will tell you what are the different column names over there. Okay, so these are the basic things which you will require when you will deal with data frames. Then one can look at a particular column of the data frame, just like what we can do with any array or something like that, right? So here, rather than mentioning the number of it, you can mention the column name inside that subsetting argument, right? So it will give you the entire column for that data frame, that particular column. Okay, you need to pass that column name with quotes, right? Okay, if you don't do so, you can do the other way also, that you can do data.bmi. That is also possible. Data.bmi. Okay, right. So this is also possible.
Okay.
I've shown that, I guess, in the below code line. Okay. If you want to rather access two columns at the same time, right? Multiple columns at the same time. So rather than mentioning a single column name, you can pass a list of column names. Okay, so I want BMI and region both at the same time, right? So I have passed a list of them to this subsetting argument, and I can get them. One more thing, this is just creating the view of that data frame. If you select those columns, right? It is not updating that data frame. So you can save this output into some other data frame also, into some other variable also. It will be a data frame only for you, right? Okay. So this is about multiple columns. You can do subsetting on the basis of a condition also. For example, if you want to look at the underweight, people's data from this data, right? So what will be the underweight people? Generally, the assumption for BMI is whoever have less than 21 BMI, those people are considered to be underweight, right? So you can look at that by just taking the name of your column, right, and then applying that condition, that less than 21. So it will give you basically the object of true and false values, right? Because this is a comparison kind of thing, right? You're comparing the values against some condition, and then you are generating that output. So it will be a Boolean kind of output over there, which you will yield out of this, right? So it's a true and false kind of thing. But if you get this condition and substitute into the subsetting argument of the data frame, you will get actual values for that, right? So if you just take this condition and substitute this into a data frame for subsetting it, then it will give you actual values out of that data frame, whichever will be true for this condition, right? Only those values will be updated or outputted. You can see the indexes are changed now, right? The index numbers are changed now because it picked out that data only which was true for this condition from the data frame, original data frame. Okay, so this is called as Boolean based subsetting or condition based subsetting. This also becomes useful in most of the cases, right? Okay. Then we can look at, just like what we have seen for the columns, we can look at the rows also, right? That is possible. Someone wants to ask something. I think I got some background.
I think it was by mistake, Sagar. I think we can.
Okay. Yeah. So we can look at the rows also, right? Just like how we have seen at the columns, we can look at the rows also. For that, there are two popular methods, right? And you need to know about this because in most of the cases, this is asked for the interviews, right? So if you want to look at the rows with their values, okay, if you want to look at the rows with their values, right, then you can utilize lock method. Okay. However, if you want to look at the rows with their numbers, index numbers rather, right? You can utilize iloc method for that, right? So let's say I want to look at the rows with their values, but for us, for our case, both the rows values and both the row numbers both are same, right? It's 0, 1, 2 and so on, right? So this case it will show you the same thing basically, and it mean to say show you the same thing, right? So we can pass 0 in both the cases and it will give you the same output, right? Okay, so this is what is there, right? When you talk about row accessing, right? Lock and iloc method. In some of the cases, you will have some categorical variables. So if you look at this data, right, which we have created or we have gone for, if you look at this data, some of the variables, that is sex, basically, this talks about of the person, right? Then smoker, basically, right? This also talks about whether the person is smoker or not, right? Then if you look at the region, right, there are 4 different regions which are mentioned into this particular column, right? So these things are not numeric, right? These are not numeric values, correct? These are some categories. So for sex, basically there are 2 categories, female and male. For smoker, there are 2 categories, yes or no. For region, there are 4 categories basically, right? So these are discrete values which are there into these variables, right? So in this kind of data, it becomes important for you to understand how the data is distributed into different categories, right? So how many values of smokers are there and how many values for non-smokers are there into this data set that you require, to understand your data better, right? So that kind of understanding you can get from the method of value counts. You can apply that method onto the column which you are interested into. So you can apply value counts onto that column, and it will give you the idea of the categories, how many number of examples are there for that category. So non-smokers are basically into my data set are 1064, and the smokers which are mentioned into my data set are 274, right? So this is an important method, you will require it. And then if you want to save the data or retain the data, right, somewhere else basically, right? Let's say, for example, you have done some manipulation onto this notebook, right? And then you have created some data, transformed some data out of it, and that data you want to retain for the future, you want to utilize it afterwards, right? Then you require to store that data somewhere, correct? Right, you have to store that data somewhere. So for that you can utilize, there is a method over there which you can utilize, that is toCSV. So let's say, for example, I create a new data frame in the name of data new from my existing data. So I told you about this, right? So you can pick out the columns and you can create a new variable out of it. Let's say data new is that new variable, and then you can apply toCSV over that data frame, because this is a data frame, right? So over that data frame you can apply toCSV, and into the parenthesis of which you can pass a path and the name of the new file which you want to create. Okay, so this is the name of the new file which I want to create out of it. Insurance 3 will be there, I guess. So let me create insurance 4, right? And this is the path of my drive, right? Google Drive. So I will be able to look at it afterwards also. It is possible, right? So I will just execute this, and then I will check my drive for this. My drive, Kolar notebooks. Let me check whether insurance 4 is there or not. Insurance 4 is there. Correct? 2 columns, smoker and charges. Okay. So this was about pandas, guys. This is all from my side. I hope definitely this was not an end-to-end thing for any of the packages, right? But it was an attempt to get you people started onto these platforms basically, or tools of data analysis. I hope you people have enjoyed this and you got something out of it, right? And again, along with that, I hope you people are doing the courses which we have given you from the skills build portal, because that is mandatory to get your certification over there, right? Okay, yeah, that's all from my side. If you have any questions, I will be happy to answer them. Go for it if you have any question. Yeah, definitely, Kajal. It was my pleasure, right, to connect with you people. Yeah. Any questions, guys? Any other points which you would like to discuss with me? Any thoughts? Yes, and the notebook will be shared on WhatsApp by Swati, right? It will be there. Okay. And if anyone is yet to take the courses on Skills Build, go for it. Please do it, right? It is necessary to go for it. And definitely you will feel the, importance of it once you start doing it, right? Because it carries a lot of value, right, into professional world. Okay. So, yeah. So thank you very much for all these 3 days participation, guys. It was really nice to connect with you people for all the 3 days. I hope you had the similar kind of experience. You enjoyed it, right? And you got something out of it, right? Through my attempt to help you out. Yes, and go on and turn on your cameras. So we will have a selfie over there. Yes, go for it. Swati, are you going to take that snap? Swati? Swati, if you are speaking, you are on mute, I guess. You are on mute, Swati. Okay, okay, okay. You don't have the microphone. Okay, is it so? Okay. Okay.
I was not able to unmute myself, so that was
Okay. I guess that is because because of coast.
Yes.
And coast.
So, students, I would like to thank all of you from the bottom of our heart, and we equally enjoyed taking up these sessions for you as much as you enjoyed, taking these sessions. So, thank you so much, students. Keep up your learnings going on. So, we have a beautiful platform called Skills Build, wherein you can upskill, you can use this time. Now we are in lockdown, and a lot of our travel time and other things are saved, so you can definitely effectively use your this particular travel time and other things for upskilling yourself and make yourself industry 4.0 ready, right? So I'll just quickly take a screenshot. So yes. So thank you so much, everyone. I hope all of you had a great time. So I request Mahesh sir, I request Bhushan sir to speak a few words about how this program was. And
Hello. Hello, ma'am. Hello, sir. My name is Professor Prokar Kremes, the HOD of Computer Department, Samartha Polytechnic. So the edu.net have been successfully arranged the last 3 days this program. and the content, whatever the delivered, the way of the delivering the content was very nice, very good, and students have definitely get the advantages of this. Whatever the content we have get it or we have delivered, and I would like to thanks to Sidde sir as well as Swati ma'am as well as all the team of edu.net for organizing all such a good sessions, and I hope that in the future also edu.net will organize such type of various courses for us, and for all the students edu.net is arranging the various online courses. So I would like to say all the students to participate in these courses. Already we have given the data, I think email IDs of all the students to the edu.net. I think that we'll get the registration user ID password to students. We will get it and we'll start that activity